Hello everyone, we are Group 21 consisting of Carl, Addie, Wilson, and Zach. Today we will be presenting to you our second project, which is our null pointer static analysis tool. This tool is used to detect null pointer exceptions in Java programs. Let's first talk about our process for this project. The motivation behind creating this null pointer tool is due to the fact that null pointer exceptions are the most common errors in Java. And we could all agree that they are very annoying for programmers and a larger code base. The purpose for this tool is to warn users about the possibility of null pointers by using static analysis. And the reason why we chose static analysis is so we can provide a reliable and efficient way to detect potential null pointer exceptions without the need to execute the code. And for our implementation of this process, we used the Java parser tool to set up the Java AST and its visitor classes. Then we figured out how to develop the analysis algorithm and its abstract state. We did this by utilizing a list of hash maps to represent a map of the general scope, class scope, and function scopes. All right, let's briefly talk about our user studies. So for our first user study, we showed them some code examples, then asked where they thought the null pointer exception would occur. And afterwards, we showed the actual output of the tool and asked them to provide us their thoughts. And for our second user study, we had our prototype done and gave our user a code base. And we told them to run the analyzer on this program and then fix any of the null pointer exceptions that were outputted by the tool. So the changes that emerged from these user studies were that we added support to more variations of our language features, and we had a clearer way of presenting the results, such as IntelliJ highlighting potential locations. Here is a quick demo of how our output changed after our second user study. So this is the output that we showed to our users, in which they suggested that it should be a lot clearer. Let's hop into our project and let's run main here, which will run the tool on this dog class. And from this, we could see the outputs in which we added this warning list, and we also have the number of errors that we found. So this is a lot clearer than before, which is a lot better. So for the evaluation of our analysis, we have determined that our design achieves 3 of the following criteria. Number 1, it is fully automatic. It always terminates, and it always says yes when there is a null pointer exception in the input program, but it does not always say no when the answer does not have a null pointer exception. And this is because it overestimates the number of null pointer exceptions, meaning there's more false positives. And also, if the tool were to be used outside of our project scope, it could be buggy and not catch null pointers. For the usefulness, we have found that our analysis is useful in preventing null pointer exceptions. And this is the case for users that want to prevent null pointer exceptions at all costs and don't mind the higher possibility of false positives. Although this would not be as useful to those who need a precise estimation of null pointer exceptions because it overestimates the possibility of null pointer exceptions. Thank you everyone for watching, and I hope you enjoyed this tool.